Literally, I have no choice. Tangent to x raised to x, that's my first step. In step 2, I have to apply natural log. Natural log y equals x multiplied by natural log of tangent to x. Like before, I have to apply the limit to both. Limit as x approaches 0 from the right, natural log y equals the limit as x approaches 0 from the right, from x times natural log tangent to x. I check again, see what happens. This is 0. This is 0 from the right, 0, natural log 0 from the right is infinity. This is a great achievement. You can say, I don't see it. Yes, it is. We managed to change the power into a product. The product normally requires an algebraic manipulation. As long as I can get away from this to any of this, specifically, I prefer these two, but even this one is better than these, it's okay. I only need now to come up with a small algebraic manipulation, and I already found it, into 1 over x. Do not try to do anything with natural log. There will be a catastrophe. You cannot move natural log anywhere. If you move it to the denominator, you'll never get rid of it. So you can also say, but you're bringing 1 over x to the denominator. It's still the same thing with x, but you will never get rid of this. Because when you differentiate, you get negative 1 over x squared. True. That's true too. But much better than natural log. I will not move natural log anywhere. So now let's see what this is. The top is infinity or negative infinity, doesn't matter. And the denominator is infinity or negative infinity. Yay, at least that. I achieved L'Hopital's rule, or a form that I can apply L'Hopital's rule. So this is negative 1 over x squared. The top is 1 over tangent to x multiplied by tangent prime secant squared to x times the inner function prime. A mess. It really is. But we'll get through it. Again, I have to try to manipulate all this and see what's going on here. I'm happy with this. Because when x approaches 0, this approaches 1. I don't have any problem there. Right? So 0 secant 0 is 1 over cosine 0, which is 1. So that's no threat. Now 2 is 2. I'm going to put it in front. I want it out of there. It bothers me. So this is 1. And now I have limit. So x approaches 0 from the right. And I can even put negative 2, so I can, these two are gone. So all I have now is 1 over tangent with x squared. So I'll flip. So this is x squared over tangent to x. So the top goes to 0. The bottom goes to 0. And I'm debating with myself whether to change this into sine over cosine or just differentiate one more time. So 0 over 0 is nice. So negative 2 is outside limit. As x approaches 0 from the right, the top is 2x, and the bottom will be secant squared 2x times 2. That's even nicer than I expected. So the 2 with the 2 will go away. This approaches 1, but I have nothing to do here. This will still be 0. So as x approaches 0 from the right, all these are gone, but I still have an x, so it's 0, and 0 times negative 2, this will be 0. Okay, now I have to copy this and copy the end and swap the operators. So in step 3, I'm going to just copy limit as x approaches 0 from the right from natural log y equals 0. I swap the operators. Natural log of limit as x approaches 0 from the right of y is 0. What can this be? It means that limit as x approaches 0 from the right of tangent to x raised to x is, and you'll tell me what is that? Natural log of what is 0? And there is only one number whose natural log is 0.
1.
1. Very good. 1. And you can say, hey, I knew this from the beginning. 0 raised to 0 is 1. No, 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 no. No, absolutely not. We can never say that. It's an indeterminate form. Okay, let's also look at a nicer one. Quite straightforward. Limit as x approaches 0 from e to x minus e to negative x minus 2x over x minus sine x. This is nice and this is straightforward. There is no headache here whatsoever. This is 1, this is 1, so 1 minus 1 will be 0. This is 0, this is 0, this is 0. It's a nice, very nice form, 0 over 0. I don't have to worry about it because it's one of the cases for L'Hopital's rule. Okay. Good, so go ahead and limit as x approaches 0, e to the x prime is e to the x. E to negative x is e to negative x, but times the inner function prime, which is negative 1, which will change this into plus e to negative x. This prime is negative 2. This prime is 1 minus this prime is cosine x. I try again. 1 plus 1 is 2. 2 minus 2 is 0. 1 minus 1 is 0. Again, L'Hopital's rule. And I can go on forever till I finish. As long as it's 0 over 0, infinity over infinity. I differentiate that. I differentiate this, but now it's negative e to negative x. This is going away. This is going away. Cosine prime is negative sine with plus in front, with minus in front. It's sine x. Again, 0 over 0. Wonderful. At some point in time, I'll be able to finish. Let's see now. The numerator prime will be e to the x, but plus e to negative x. And finally, the denominator is cosine x. 1 plus 1 is 2 over 1 is 2. Although it was cumbersome, it was straightforward. Any questions? Any questions? Here's an interesting one. Like a limit as x approaches 1 from the right of natural log x to the 7th minus 1 minus natural log x to the 5th minus 1. So this is going to 1 from the right. So this is 0 from the right. So this will be negative infinity. This will be negative infinity, but it has a minus in front. So it's the indeterminate case, this. No, you cannot conclude what this is. It's the difference. Infinity minus infinity. So we don't know what that is. But I could change this function into limit as x approaches 1 from the right. Natural log minus natural log. It's the same with natural log of the ratio. Are we familiar with this? Do we remember this property of log? When we have log of a function minus log in the same base of another function is basically log of the ratio, this at the top and the one with minus at the bottom.
Yes.
Perfect. So now, when I determine the limit inside, it is, what do I get inside when so limit from, when x approaches 1 from the right, the numerator goes to 0, the denominator goes to 0. So at this point, I can swap the operators and have natural log of the limit as x approaches 1 from the right from x to the 7th minus 1 over x to the 5th minus 1. So this is natural log. We know the answer, but I would like to show you. So this is limit as x approaches 1 from the right. I differentiate the top and get 7x to the 6th. I differentiate the denominator, I get 5x to the 4th. I simplify, and I still get an x squared, right? So when x approaches 1 from the right, this is 1. So this is 7 over 5. So this limit equals 7 over 5. And the answer then is natural log of 7/5. So you didn't expect an infinity minus infinity to be this. That's why we call them indeterminate. They can take any form. I don't want to start optimization. We have optimization and Newton's method tonight. So could you tell me which kind of limits you would like to look at? And I just wanted to see when did we announce our test 3, because I want to plan ahead and have a review, etc., etc. I'm trying to get back. I have so many windows open. Okay. If you remember, let me know. If you don't remember, I'll find it. It's in the calendar, so I'm just clicking on the calendar right now. And tell me, we have like 7-8 minutes. I would like to know which kind of function or limit you would like to see. And please, 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 I'm begging you, I have a 3 or 4 question. I think it was 3 or 4. Yeah. Chapter 3, test 3, 14th. 14th. So, well, I will have to change that either to probably the 16th. Most probably, I will move it to the 16th, test 3. Monday, 2 weeks from today. Yes. I already moved it, and I'm going to move the rest of the assignment. Okay, so what type of limit you would like to? We have a few more minutes, 5, 6, 7 minutes or so. What type of limits you would like to go back to with L'Hopital's rule?
For the problem you just did.
Yes.
So you swap the operators because
I still have to determine this limit first.
Mm-hmm.
Yes. So I have to determine this limit and then apply log to it.
Oh, okay.
So
is it just easier to find the limit?
I have to.
In that order?
I have to.
Okay.
I have to. I cannot determine log without determining the limit here inside and then applying log to it.
Okay, gotcha.
Yeah.
Okay.
Good. Other questions here? If you don't want to look at another limit, let's look at the quiz. So see if you have any questions about the quiz.